Moving on to part B, we're asked to find the probability that x is less than 2. So when we want to find the probability of a discrete random variable, the probability that x is less than 2 is the probability that x equals each of the values less than 2 that it can take, because x here can be one of 0, 1, 2, 3, or 4. So if you, for example, a binomial random variable with n equal to 4 and 9/10 probability of success, that could be flipping a very biased coin. So it's 9/10 chance that it lands on head. You flip it 4 times. How many heads do you get? Between 0 and 4. So the probability that x is less than 2 is the probability that x is either 0 or 1. So that's probability x equals 0 plus probability x equals 1. And then the probability that we obtain a certain number of successes is given by the probability mass function for a binomial random variable. And that is, again, there in your formula sheet. So in the formula sheet, under the probability section, we've got the probability distribution for a binomial random variable, and the probability that the random variable x has a certain number of successes, little x, is given by this formula on the right hand side. So we can go ahead and apply this to our question. So I'm just going to write down the formula for the probability that x equals a certain number of successes. It's n choose x, p to the power of x times 1 minus p to the n minus x. Then we can go ahead and use this for x equals 0 and x equals 1. So the probability that x is less than 2 equals the probability that x equals 0 plus the probability that x equals 1. That equals n is 4, so we've got 4 choose 0. Probability of success is 9/10 to the power of the number of successes, which is 0. And then we've got 1 minus p, so 1 minus 9/10 is 1/10. N minus x is 4 minus 0 is 4. So that's the probability that x equals 0. And then we've got to add to that the probability that x equals 1. So that's 4 choose 1. Again, 9/10 chance of success with 1 success. And then 1 minus p is 1/10. The power of n, 4 minus 1 is 3. So evaluating this, 4 choose 0. How many ways are there of choosing 0 things from 4? There's exactly one way of doing that. So that is